Science Screen Report for kids. Answers the what, why, where, and hows of our world and your part in it. In this exciting video encyclopedia made especially for you.
Without light, we can't see. That is because we don't actually see objects at all. Instead, we are seeing the reflections of light off the surfaces of them.
Why can't we see the objects themselves?
Only things that give off or reflect light are visible. We can see the sun. We can see a fire or a light bulb. But an object that doesn't emit light is not visible until light strikes it.
So then what is light?
Light is a form of energy. The light from the sun is produced when two atoms fuse and release energy. The light from the sun is so bright we can't even look at it directly, even when the sun is behind the moon during an eclipse.
But can't we make light here on Earth?
Yes, we can. In fact, we can produce light, measure it, break it up into different wavelengths, and even use it to carry information. In this program, we will take a closer look at light and its reflections and see how light is put to work in our world. A long time ago, people thought that some inner light shot out of our eyes, lighting up everything in view, just like how a car's headlights work. Later on, others thought we could see because rays of light hit our eyes and then bounced onto the objects we were looking at.
When did we find out what light really was?
About 1,000 years ago, a man named Ibn al-Hazan realized that when we look at something bright, it hurts our eyes. This made him think that light must be entering the eye, not leaving it. And now we know that natural light comes from the sun, that it bounces off objects and then enters our eyes.
Is light the only thing we get from the sun?
The energy from the sun comes in many different forms. Light is only one of the forms. But the sun also makes radio waves, X-rays, ultraviolet waves, and other forms of radiation.
How come we only see the light from the sun and not the other things?
Our eyes are only able to detect light. But even then, the light energy has some amazing properties. The white light we see is actually not white at all. It is made up of all the colors of light in the visible spectrum.
How can white light be made up of colors?
This prism will show you what I'm talking about. The white light is broken up by the prism into different colors. The prism separates the colors of the light by their different wavelengths. It turns out that each color of light has its own specific wavelength.
So how do objects have colors?
Well, unless an object is transparent, it either reflects or absorbs the light that hits it. The color that an object appears is the color that is reflected. For example, let's take a red object. It absorbs all the light that hits it except the color red. And a blue object absorbs all the wavelengths of light except the blue. If something is white, it reflects all visible light. And something that is black absorbs all visible light.
What happens when light strikes objects that are shiny?
Some smooth surfaces like glass, polished metal, and still water bounce all the light back, and we see a reflection. The best reflector of all is a mirror.
How is light reflected?
Since light is a form of energy, whenever it strikes an object, some of the energy is absorbed by the object. Reflected light is simply the energy that the object does not absorb. A mirror absorbs almost no light and reflects almost all light. We can see how this works by using a mirror, a dancer, and a television camera. If the camera is here, it can't see the dancer's reflection. But as the camera moves, the dancer comes into view. Now you see her. Now you don't.
Does light always bounce off a mirror in the same way?
Not really, but light behaves in a very predictable way. Light always travels in straight lines. And if you shine the light at an angle, it will always be reflected at an equal angle. These three parallel rays show you what I mean. The ray from the light source comes in at one angle, and the reflected light from the mirror goes away at the same angle.
But how does that help us understand light?
Only some of the waves of light striking the dancer are also hitting the mirror. These are the only rays that we can see. Waves of light that bounce off in other directions are not hitting our eyes when they reflect off the mirror, so we can't see them.
Is that why the camera has to move to pick up the dancer's reflection?
Yes, the camera can only pick up the reflected light coming off the mirror if the camera is within the angle of reflection. So, to make the dancer visible, the camera has to move into that area. Because, don't forget, light always travels in straight lines.
So light just keeps going until it strikes an object?
That's right. That's how we see. And behind the object that is in the light is a shadow. This happens on a grand scale when the moon gets between the sun and the earth, creating a huge shadow on our planet. Because light always travels in straight lines, only the area directly behind the moon is in total darkness.
Does the moon block the sun very often?
Solar eclipses are rare because the earth, sun, and moon are always moving. When the moon passes between the sun and the earth, its shadow travels around the world for a while, and then the moon moves out of the way, and the eclipse is over.
Can we see a solar eclipse?
Yes, you can, but you'll need some special equipment. Scientists set up telescopes to record eclipses. Young scientists who do not have a telescope can use glasses with special filters to view it.
So what actually happens during an eclipse?
The light slowly dims as the moon passes in front of the sun until our star is completely hidden and the crowd is plunged into darkness. Then the daylight returns.
Wow! What's that ring of light around the black circle made by the moon?
That's the corona, or atmosphere, of the sun. And the only time we can see it is during an eclipse. That's one of the reasons scientists study eclipses.
Isn't a solar eclipse a little scary?
You know what? We didn't always know what caused an eclipse. And all over the world there were stories about monsters eating the sun. Big cats in Argentina, giant frogs in Vietnam, and dragons in China. In ancient China, they tried to scare that dragon by shooting arrows at it. But the Chippewa Indians in North America had a different idea. They shot flaming arrows at the sun, thinking it needed relighting.
I'm glad we know more about it now.
I am too. But some legends were really interesting, like the one that tells how two tribes had been fighting for 5 years. When it got dark in the middle of the day, they saw it as a sign to immediately end their war.
That's a good story.
It is, but I think the best story is from Tahiti. They thought the sun and moon were in love, and the only time they could touch was during an eclipse.
I just thought of something. The moon is much smaller than the sun, so how can it block out the sun?
That's a good question. The sun is 400 times larger than the moon. These students wanted to know the answer to that too, so they set up an experiment that used a bead to represent the moon and a model sun that is 400 times as big.
How does the experiment explain the solar eclipse?
Well, this boy represents the Earth. He holds the bead that stands for the moon 25 centimeters away from his eye. Then the other kids move the sun farther and farther away until the bead completely blocks it out. At 20 meters, the moon still appears too small to cover the sun. And 50 meters doesn't work either.
When does the bead cover the sun?
The distance between the boy who's being the Earth and the bead is 25 centimeters. Because the sun is 400 times larger, it must be 400 times that distance, or 100 meters, for the sun and the moon to appear to be the same size.
That makes sense. But it's amazing that the sun, the moon, and the earth are just the right distance apart to create a solar eclipse.
It certainly is. There is a lot to be amazed about when you think about the sun. For instance, how much energy it produces and how it affects the earth.
How does the energy from the sun affect us?
Everything on Earth, from the rainforest to the ocean, depends on the energy that comes from the sun. Heat from the sun warms up the oceans, and this energy helps cause our ocean currents. It also helps to create the Earth's weather.
But how does the sun produce so much energy?
Inside the sun, it is so hot and pressure is so great that hydrogen atoms are ripped apart and fused into helium and other elements. When these atoms fuse, a great deal of energy is released that goes out into space.
Do you think the sun will always produce energy?
The sun has been producing energy through nuclear fusion for over 4.5 billion years. Scientists expect it will continue to produce energy for 3 or 4 billion years more. So I guess we don't have to worry about not getting enough sunlight.
But we could also make light, can't we? What about lasers and things like that?
Yes, we can. A laser is when you have a single beam of light traveling in one direction that has been amplified. Light from a laser can easily pass straight through water. If you change the position of the laser, then the beam is reflected off the surface and back into the tank.
Wow, that's neat. What else can it do?
We can get the light to travel through this stream of water even when it is curved. We can even get it to move through a curved piece of glass.
But why would we want to get a light to travel through curved glass?
Natural light always travels in straight lines. By using a laser and these glass fiber optic cables, we can use light to carry coded messages to any location on Earth faster than ever before. It's the secret behind modern telecommunications.
What's inside a fiber optic cable?
Inside this fiber optic cable are thousands of fine glass fibers, like the ones in this lamp. When we shine a light at one end, it gets through to the other no matter how curved the cable is. So what do you think? Did you learn anything today?
I sure did. I learned how light bounces off objects and makes it possible for us to see.
So what are we seeing then?
We're seeing the light that's reflected off the object. That's why things have different colors too.
That's right. So where do we get most of our light?
From the sun. The sun releases all kinds of energy, including visible light.
Right again. So tell me this. What causes a solar eclipse?
A solar eclipse happens when the moon passes in between the sun and the earth and casts a shadow on our planet.
Very good. Just one more thing. How does light act after it is reflected off of something like a mirror?
Oh, I know that. The angle it comes in on is the same as the angle it leaves on.
Excellent. Isn't it great how much we've learned about light and its reflections? Although we've always relied on visible light from the sun and other sources to see the world, it wasn't until just a few decades ago that it became possible to put it to work for us in communications. Lasers are an important factor in modern communications. And today, more than ever, we depend on light to help us live full lives. We can also expect that scientists and engineers will use their understanding of light to make further advances to improve our lives and the technology that we utilize.